Oh man, I'm running late. Oh no. One more, I got assist.
Wilson arrives 20 seconds before the bell rings with a distance of 300 feet between his car and the pods and an extra distance of 60 feet between the pod entrance and Mr. DeWalder. That's a total of 360 feet he has to cover. With an acceleration equation of 4 feet per second and a max velocity of 18 feet per second, Wilson travels 4.5 seconds to reach his max velocity of 18 feet per second. That's a distance of 40 feet covered in the first 4.5 seconds. For the next 15.5 seconds, at 18 feet per second, he travels 279 feet, plus the additional 40.5 feet to cover a total of 319.5 feet. That does not equal 360 feet. Wilson is late.
Trade on the top, quality party suite.
Where's your pass?
I don't have one.
You don't have a pass?
Wait.
Jams is here to have fun. I don't know about y'all. Yeah! We used to be so carefree and live so well, and we would take adventures and live to tell. We used imagination instead of drugs. We never gave out daps, but instead gave hugs. Yeah, hey, but look where we at now.
Here we have Where's Your Hall Pass with Nick and Miss Parsons. Nick's acceleration is 0.5 feet per second squared with a velocity of 0.5 t feet per second. And that gives you a displacement equation of 0.25 t squared plus 4 feet because his displacement was 4 feet ahead of Miss Parsons. Over here, we have Miss Parsons' acceleration at 2 feet per second squared, a velocity of 2 t feet per second, and a displacement function of t squared feet. If you set them equal, you come out with the time of 2.31 seconds that they made up. Over here, we simply have a graph explaining that, with Miss Parsons being the red line and Nick being the purple line. They meet at 5.3 feet.
We use imagination instead of drugs. We never.
My life be like, yeah. My life be like.
So if Wilson starts 100 feet from Kyle, and Kyle's accelerating at 9 meters per second squared, and his velocity is at 9 t meters per second, then his position is 4.5 t squared meters. If Wilson's accelerating at 4 meters per second squared, and his velocity is at 4 t meters per second, then his position is 2 t squared plus 100 meters. If we set the two position equations equal, we find that at 6.35 seconds, that is where their displacement meets.
Low key and staying candid, reflect on all the things I try my hand at. Search for the equation to persuasions I'm used to, find a comfort in the zone.
Nick's acceleration is 0.5 seconds.
You are crazy slow.
Well, yeah.
Alright, here we have Where's Your Hall Pass with Nick and Miss Parsons. As you can see, Nick's acceleration equation is 0.5 feet per second squared. His velocity is 5 feet per second.
That's definitely 0.5 t meters per second, and his position is 2 t squared plus 100 meters. What is this word?